Assalamualaikum, my name is AIDA binti ZAKARIA, memiliki nama DE1 NASIR 020. I want to explain about the question 1. What type of medical electronic circuit that you choose and why? The type of medical electronic circuit that I will choose is electromyography EMG. What it is used for? Electromyography in EMG help figure out where the trouble is in the way resistant word. The diagnostic tool is very valuable in the differential diagnosis of nerve and muscle disease. And then to find out when different muscles start moving together, it is important to synchronize the device that provides cinematic data with electromyography. EMG is becoming increasingly significant in sport medicine, occupational medicine and ergonomic study, and facility in hand performance and reduce injury danger. The most important point to achieve healthy training are the follow-up, adjustment and performance correction where necessary. Okay, and then develop a simulation that can help harder encounter this device problem. And what the function? Electromyography in EMG is a technique used to assess and record the electrical activity generated by skeletal muscle with facility movement by applying force to bone and joint tendon via contraction. And next, perform with the help of a device called a electromyograph to make an electromyograph record. When nerve or electricity stimulate muscle cell and electromyograph record the resulting get the electrical potential. And then signal can be analyzed to detect abnormality, measure activation level or requirement order or examine human or animal biomechanics. And then needle electromyograph is a form of diagnostic medicine and also common electrodiagnostic medical products are done by neurologists. Okay, for the next slide.
Assalamualaikum warahmatullahi wabarakatuh. My name is ZULAIKHA binti ZAMRI. My metric number is CE19203. So, for this EMG circuit, I will continue with the question 2, which is the logic behind the use of component and the process involved in it. Okay, the list of component, it have 5 main component. The first one is that LT1014 OM and H11AA1 optocoupler, Arduino Uno, wireless transmitter receiver module, and also electrode with a reusable probe. For the quad precision operational amplifier, the function for this component is that it is employ the application part of the EMG biopotential amplifier because it has a total gain of 10,000 and can amplify the weak electrical signal and become more strong. For the optocoupler, it operates by passing light from the LED to the photodiode on the receiving side. This is done by sending a DC current through the LED. But when the AC is put into the LED, the photocoupler not only send out a signal every half cycle, but the LED could be in danger of receiving a fatal damage. For the input can operate by turning the photon into electron in the base of a bipolar transistor. It uses this to measure the amount of light and then change the flow of the current between the emitter and the collector terminal depending on how much light it gets. It also the logic input create an input side current which that create corresponding LED output. This output is sent through the mounting compound barrier to the photodetector and the output of the receiving photodetector. Okay, right now I will explain about the process that involved in this EMG circuit. So as you know that the first part to get the EMG signal was divided into the 3 parts, which is amplify, insulation and also filtering. The instrumentation amplifier design of the OM was of the LT1014 was based on the 3 standard OM. The instrument amplifier is made of 1 input, buffer and differentiation OM design. The differential amplifier boosts the voltage difference between the 2 sources of the EMG signal picked up by the bipolar non-invasive skin electrode. The input buffer used to transfer a voltage from a first circuit having a high output impedance level to a second circuit with a low input impedance level. The interposed buffer amplifier prevents the second circuit from loading the first circuit unacceptable and interfacing with its desired operation. While another one left is used for voltage follower, which gain of 1. This is provide very high input impedance and insulate output from the signal source, hence avoid the loading effects. The function of Arduino Uno is that Arduino Uno board can be used to build prototype of EMG sensor. The Arduino board has a built-in circuit that can read the value coming from the sensor and then process them using the software. For the XB wireless transmitter receiver module, The function is use various communication protocol to send information such as data from a sensor. Radio frequency module communicate through a gateway while a cellular XB connect over cellular network. Then to send the information such as data from a sensor, the radio frequency communicate through a gateway while cellular XB connect over the cellular network. Okay, right now we'll explain about the component of AG, disposable electrode with reusable probe. So the function for this disposable electrode is that it provides accurate and clear transmission of surface biopotential. So it is suitable for the EMG. And then EL250 series reusable lead electrode are suitable for most applications such as ECG, EEG, EGG, EMG, EOG, and also ERS recording.
Assalamualaikum and hi, my name is Nora Nisah binti ALUI. My metric number CE190140. I will continue for the question 3. How do you conduct the simulation? So, first thing first, to simulate the EMG circuit using Multisym, we begin by launching the software and opening a new project or an existing one. Okay, next, we design our circuit by selecting the necessary components from the Multisym component library and placing them on the schematic. And then we connect the components together based on the desired circuit configuration, ensuring proper electrode and signal processing element connections. And then we adjust the properties of each component by editing their values, and then we define the input signal for the circuit, either through a simulate muscle activity signal or by importing an EMG signal. We set up the simulation parameters such as time, step size, and analysis type such as SE analysis. And then we proceed to run the simulation and observe the results by analyzing waveforms, measuring voltage and currents at specific point, and we utilize Multisym's analysis tools and oscilloscope. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Salimah binti NASIR. My metric number CE190189. Today I would like to explain our result for EMG circuit. As you can see in my left side, this is the circuit of EMG. We are using the Multisym online, and the right side is the waveform of the EMG, which is the output. We use the AC swap one, and for the input of voltage, we use 5 volt, and the frequency is 500 Hz. And as you can see, this is the graph of EMG circuit, which is they are converted from all the process, and then he pop up the last, which is the one paragraph. And as you can see, this is the paragraph which is combination for magnitude and phase. So we can check for the magnitude and we click the setting. Okay, this is for the circuit. If we want to check the axis, you can see this is the axis Y and this is the axis X. So for the cursor one, we got 20.893 Hz, and for the dB is 32 dB, and for the circuit 2 is sorry, it's not the circuit 2. Cursor 2 is 436.5 Hz and negative 320 dB, and for the maximum and minimum frequency that we choose is until 10K, and for minimum and maximum decibel dB, which is minimum is negative for 340, and 40 dB, and maximum is negative 300. And otherwise, its phase is minimum negative 100 and maximum is 200, which is the positive. As you can see, the result is the EMG circuit, and which the parameters that we use for the frequency, like as I say, like before, this is 1 until 10K, and this signal have convert analog to digital signal, and it pop up on the one paragraph only. That's all from me. Thank you.
Hi, Assalamualaikum. So my name is Asma Diana. I will continue this presentation with question number 5. It is about self-reflection. Alright, so for the first question, it is about what we have learned throughout this project. So basically, in this project, we learn on how to conduct a circuit simulation on signal conversion of EMG biopotential amplifier by using Multism software. Alright, so for the software, we are using Multism. And we also learn on how to analyze the EMG biopotential amplifier circuit using analog to digital signal conversion, ADC. And the last one, we also understand on the concept of amplifying, isolation, and also filtering the EMG signal. So there are a few challenges that we have encountered and we have overcome in this project. So for the first challenge, it is about loading effects, which we interpose buffer amplifier to provide high input impedance and to isolate the output from the signal source. And the second challenge, it is about noise elimination. So we are using the optocoupler, which is used to block the electrical noise from signals by isolating it away from another part of the circuit and to safely isolate people from dangerous electrical systems. And for the third challenge, it is about signal classification, which is we use a program to smoothen and squaring the output signal that implemented. So it is to differentiate larger parameter range of within 4 types of significant signals generated to fulfill DC jet motor truth table for motor drive applications. So that's all from my part. Thank you.